Today we're going to learn about the binomial theorem. What that is it's how do you use Pascal's triangle and the NCR notation, which, don't forget, NCR can also be written as NR. So that's the notation that we use. So we're going to learn today how do we use this to expand expressions in the form of a plus b to the power n, where n could be any number. A and b could also be anything, but we'll use this as a general form to expand. Alright, so the first term of this expansion begins where we use the nth row of Pascal's triangle and then the naught position. And we know the naught position is 1. So this is always going to be 1. So often in general terms you won't see NC0, it will just be a to the n that's left. Now, a to the n is the first term put to the power. What happens in the next term if we then go to the next number in Pascal's triangle, so NC1, so obviously the first position on the nth row, and then we decrease the power of a by 1, so we go a to the n minus 1, and then we start moving on to the second term in the brackets, and that slowly increases. This is currently b to the power 0, which we know is just 1. So now on this one it's just b to the power 1, okay, which we just write as b. The next term in an expansion, we move along to the next position in the nth row, so it becomes NC2. This term then decreases by 1 power, so it's a to the n minus 2, and this term, or this part of the expression, apologies, increases by 1, so it becomes b squared. Now this continues all the way, obviously I've pre-written this, continues to the general term. Now this here, this part of the expansion here is what we call the general term, and we're going to look at that a little bit later. And then we keep going, so we're continually increasing this power, but decreasing this power. So eventually we get to the final number, the final position in the nth row, which is of course n, which we also know is just 1. And then we've got reached the maximum power for this part of the expansion b, so obviously b to the n. So now at this point, I guess this is a to the 0, which we know is just 1. And that is the binomial theorem. Now you may see it written in this notation as well. Instead of using NCR, it may be just NR written like that. Obviously you need to know what both of them mean. Now what you're going to do in class is you're going to use this general expression to be able to expand expressions like x plus y squared to the power of something like 4, 6, could be anything, all right? And you'll use this to help expand. Now let's just have a look a bit more at this general term. All expressions, when you expand this, you're going to have several terms. If it's a quadratic, we know it has 3 terms usually, not always obviously, depending on what these two numbers are. If it's the cubic, there are more terms, quartic, more terms, and so on. So what we obviously find is the higher the power, the more terms there tends to be, and often it's not efficient for us to do the entire expansion. So sometimes we just want to know, well, what's the coefficient or what's the number that's in front of this particular term of the term that's x cubed y squared, for example. And I'll show you how we use this in class, but I'm just going to make some notes on this. So this allows us this general form. I'll just talk about this inequality here. We know the way Pascal's triangle works is that r has to be less than or equal to n, because we know that the final position on Pascal's triangle, like if we just look at row 2, for example, the final position is when when r equals n. So we've got 2c2, apologies. So that's 2c2 at that point. This we know is 2c1, and this position is 2c0. So remember, this can be written as 2, 2, 2, 1, and 2, 0 in this notation here. Now I've already talked to you how we use this, obviously, because I've done some examples in class, but we do need to know that r has to be less than or equal to n, but we know it's got to be greater than or equal to 0 in order for this formula to work. Now we use this general term to find the coefficient, or perhaps other things. I might give you a constant term and say, okay, tell me what's the coefficient of the constant term. Obviously, if it's a constant term, there will be no variables within the expression, so you really have to think deeply about this. In class, I'll show you how to do and how to use this formula to find coefficients of x cubed y to the power 6 or something like that in a particular expansion, such as x minus 3y squared to the power 6, something like that. Okay, so that means we don't have to expand the whole thing